Welcome to the next dimension, where we take the most complex questions of the universe and break them down into logic that actually makes sense. Today, we are tackling one of the biggest debates in science and philosophy, the mystery of the fourth dimension. Specifically, we are diving deep into the great debate of space versus time. For decades, popular culture and even some scientific theories have told us that the fourth dimension is time. You've probably seen it in movies or read it in science fiction. The idea that if you could just step into that fourth direction, you'd be traveling through the past or the future. But if we look at the universe through the lens of pure mathematical progression, we find a very different story. According to the logical patterns that govern our reality, there is a fundamental and crucial distinction between spatial dimensions, like length, width, and height, and the non-spatial dimension of time. To understand this distinction, we have to go back to our basic building blocks. Imagine our folder metaphor again. If we take a single folder and assume it has no height and no depth, we have a one-dimensional world, a simple line where an organism can only move forward and backward. When we move to the second dimension, we stack an infinite series of those 1D lines to create a plane with width and length. When we move to the third dimension, our own world, we stack an infinite series of those 2D planes to gain height. This is a consistent repeating pattern of spatial stacking. Following this logic, the fourth dimension should be a spatial direction as well, an infinite series of 3D worlds stacked together. If the fourth dimension were time, it would break this beautiful mathematical pattern. In a spatial 4D world, we aren't talking about when things happen. We are talking about a new where. The source makes it very clear: time is not spatial. There is an obvious difference between the space we occupy and the time that passes within it. One of the strongest arguments against time being the fourth dimension is the pattern argument. If we assume that all dimensions follow a consistent pattern, then saying the fourth dimension is time simply doesn't add up. Why? Because every dimension has time in it. A one-dimensional creature living on a line experiences time as it moves back and forth. A two-dimensional creature living on a flat plane experiences the passage of time as it explores its world. We, as three-dimensional creatures, obviously experience time. If every lower dimension already contains time, then making the fourth dimension time would make it special in a way that doesn't fit the mathematical sequence. It would be like saying the first dimension is a line, the second is a square, the third is a cube, and the fourth is a Tuesday. It just doesn't follow the geometric logic of adding a new perpendicular direction. When we talk about spatial dimensions, we are talking about the logical progression of mathematics. In a 1D world, one line meets at a vertex. In a 2D square, two lines meet at a vertex at 90-degree angles. In a 3D cube, three lines meet at a vertex. To reach the next dimension spatially, we need a shape where four lines connect to each vertex, all perpendicular to one another. This shape is the tesseract. Time cannot provide that fourth perpendicular line. You cannot walk left, up, forward, and then time at a 90-degree angle. Time is a separate variable entirely. While some argue that moving forward and backward in time is like moving in a fourth direction, this is more of a metaphorical comparison than a mathematical reality. To further clarify this distinction, the source points to the fascinating world of physics and time dilation. We know that space and time are connected, but they are not the same thing. The source explains that we actually travel through time very, very slightly whenever we move. This is most extreme when we talk about the speed of light. Imagine a group of astronauts who get into a spaceship that can travel nearly at the speed of light. If they were to travel in this ship for just a few months and then return to Earth, they would find that years had passed on our planet. They have moved forward in time because of how fast they were moving through space. This proves that time is a coordinate that can be stretched or compressed by spatial movement, but it doesn't function like a spatial dimension where you can freely choose to walk north or south along a timeline. Another reason the time as the fourth dimension theory falls short is the concept of the 4D observer. If the fourth dimension were just time, a 4D creature would simply be someone who could see the past and future. But if the fourth dimension is spatial, a 4D creature has a much more radical perspective. They can see through things in our 3D world. Just as we can look down at a 2D drawing and see the inside of a circle, a 4D spatial observer could look at our 3D world and see inside houses and even inside of people simultaneously. This inside-out perspective is a result of having an extra direction in space to look from, not from watching a clock. Furthermore, there is the theory of the curved universe. Many physicists and mathematicians suggest that dimensions are not infinite lines, but are very slightly curved because nothing can be truly absolutely infinite. If a 1D line curves, it eventually forms a circle. If a 2D plane curves, it forms a sphere. If our 3D world is very slightly curved, it forms a 4-dimensional universe. This curvature happens in a spatial sense, meaning our 3D world is tucked inside a 4D world, which is inside a 5D world, and so on. This creates an infinite series of spatial worlds, rather than just one world with a timeline attached to it. In conclusion, while it's tempting to call time the fourth dimension because it's a concept we deal with every day, the mathematical evidence points elsewhere. Space is about where, the length, the width, the height, and the next direction that allows us to see through walls and connect 4 lines at a single vertex. Time is about when, the medium through which all dimensions exist and move. By keeping these two concepts distinct, we can begin to truly perceive the tesseract not as a time machine, but